Hey everybody. It's nice to see some of you. Some of you are new here. I think I met a few of you at Developer Week. Glad you guys were able to make it out and find a place. Feel free to eat up all that pizza. There's going to be plenty left, so if there's any left at the end of the night, feel free to take it home. Today we have two talks. One, the first one's going to be by Mario, who's going to be talking about building a static website with a headless CMS. And then second, we have Cass, who's going to be providing some really cool gadgets. It looks like some cool demonstrations there. If you guys have any questions or anything, we talked about it after the talks. There's stickers up here. Some of you from Developer Week probably already have some of these. And my business card's up here as well. If you're interested in giving a talk or know someone that's interested in giving a talk, just feel free to take one of those and email me. Otherwise, Mario,
What's up, guys? My name is Mario. I work here at the Knot. Lately, I've been doing a lot of like React and React Native stuff for the Knot. So if you want to talk about that stuff afterwards, I'm more than happy to talk about that. But today, I'm going to be talking to you guys about how to build a static website with a headless CMS. And I came across this architecture kind of motivated out of cost because I'm like the computer guy, my people friends, as probably most of you guys are. So everyone's like, oh, you make websites. I have like this like little, I'm a photographer. I want to make a photography website. Or I'm a wedding planner. I want to make just like a little marketing wedding website. And they didn't really have money to give me, just my friends. Okay, cool. Which is like a lot of the case. So I didn't want to like install like a CMS like WordPress and host that on a server. So I basically started off by making these websites as static sites and kind of evolving that, and really driven out of cost, decided to move towards headless CMSs because there's a lot of free tier offerings on these services, and the only cost associated with hosting and having a headless CMS is basically the cost of your domain name. So there's a little bit of a misnomer with this, the name of this talk. It's actually going to be a website for the cost of a domain name. So it's kind of different. So if you have like a .biz or something, it's probably less than $1. But if you have like a .com, then you're kind of up there. So I'm going to talk about, I'm going to do a little bit of a web 101 just so we're all on the same page. I'm going to discuss the difference between a static and a dynamic website. We're going to build a static website, and we're going to kind of follow through with that static website and integrate with the headless CMS. We're going to discuss what a headless CMS is, integrate the headless CMS with a static website, and then we're going to get into like a live, hopefully it doesn't mess up, hosting and CI/CD of this static website. I was like making this talk, and I was going to make slides for hosting and CI/CD, and then when I integrate it, I was like, this gets so static versus dynamic. I want to stress that it's not what is better. There is no better solution on static versus dynamic. It's that both have their pros and both have their cons. Both have their use cases. So as you can see here, the contract between the client and the server is the same. It sends a request and expects a response. But what happens on the server is a little bit different between static and dynamic. Static, it's looking for basically a static file on the server, and it takes that file and it gives it to the client. So index page, you go into the index at the HTML page, here it is, done. That's the process. Dynamic, there's a little bit more going on. A lot of the stuff that's going on usually is like it's contacting the network to get some more information. It's hitting the database to modify that response into basically the end result is going to be the same as an HTML file. The only way to change content on a static website is to actually physically change that file on the server. For dynamic, the process that's happening in the background can be changing that content on each response based off the logic that's happening on that handler. So let's build a static website and let's follow through with this. So an example use case, and this is kind of recently actually, one of my friends, he's a photographer, and he wants to start his own design company. And he bought a domain that has a .design, so that was actually pretty cheap, so kind of cheap for this talk. And he had a bunch of images. I want to say like maybe like 30 or 40 images. So the first iteration of what you can do for a project like this is just build a static HTML page, right? It's images and it's just content. You can just store the images on the server, and you can just build an HTML file and you can just show it. But you can see here, as a good engineer and a good web developer, you're going to see something that's kind of bad here. And the bad thing is that there's this duplicate code right here. So say he had like 100 images in his gallery, and I wanted to change that way that image is actually displaying. I'd have to change it 100 times, at least the CSS classes, or maybe the structure of the HTML, and that's not maintainable, it's not scalable. So as a good engineer, I was like, what can I do to solve this problem? How can I kind of get like a dynamic feel, sort of, but for a static website. And that's when static site generators come into place. There's a bunch of offerings that do this. They all do the same thing. They take some source code, they do some kind of process, and they build a distribution folder that's basically the end result is going to be always this. Bunch of different offerings. They do it in different ways. They almost always have templating. They almost always have a way to manage your data coming into that templating service and build off of it, loops, if statements, that kind of deal, but in your HTML files. You probably know Jekyll. That's usually what they use for GitHub Pages. Gatsby's coming up. That's like React. So you can write React, and it compiles it into static web pages. And there's a bunch of other offerings. I'm not going to show you any one of these, basically, because they all deserve their own talk, because it's basically a framework you're building on. So I'm going to implement a rudimentary static site generator using Gulp. So if you guys know what Gulp is, a task system for Node or whatever. And I'm going to implement it in like 2 Gulp commands. And it's going to give you a good idea of what it's doing. It's not going to be as robust, obviously, as these systems, but it's going to give you a good idea what's going on. So the first thing I'm going to do is I'm going to take, my previous project was basically an index.html file in an assets folder. And to get that on the server, you could literally just like FTP, put it on a server, and you're done. Cool. But now I'm going to have a build process. So the 2 commands that are going to happen is I'm going to copy my assets, which is my assets folder, from a source directory, and I'm going to put that in a distribution directory. So cool, I have images, take it from the source, put it in the dist. And then what I'm going to do is I'm going to use something called Nunjux. It's a templating service for JavaScript. It's very simple. And I'm going to use a Gulp plugin that's going to take that the source file that's templated using Nunjux. It's going to pipe in some data. My template's going to do something with that data and build some HTML, and it's going to put that in my output folder. So you can see here, what I'm doing is I'm calling a gallery service, saying get galleries from the gallery service, and this is going to return like an array of images for me. So I abstracted out that piece into a service. What that looks like first iteration is basically just like, it's a static file still. It's still static. So I pipe in URLs and alt tags for images, because we're good developers, you have alt tags, and these are great description alt tags. And here's what my index file looks like now. You can see it changed. This is the Nunjux templating service. So my HTML file knows now that I have like a global images array. I'm going to loop through that array and pipe out some of this content automatically, which is going to end in, it's going to result in a very similar structure to this. So now where are we in that build process? What does our build process look like? So on our local machine, what we're doing is we're taking in that gallery array, we're taking in that templating HTML file, we're piping it through a Gulp build process, and it's compiling it and taking it into a dist folder. And now there's that manual process of however you want to get it onto your hosting provider to get that static stuff into a web server, and that's where it plugs into the static website ecosystem. And that's all great. The client loved the website. It looked fantastic. But then requirements change a little. Now my friend wants the ability to change those images without calling me. He doesn't want to get on the phone and be like, hey, Mario, can you add this one image? I just made it. Here's a file I'll send to you in Google Drive. I got to get it. I got to recompile my local machine. I got to grab the file. I got to put it on the server. He doesn't have to do that. He wants to do it himself. He wants to just show up on the site like automatically. He also noticed that the images that I put on were full resolution on the gallery. So every time I loaded the index page, I got full resolution images in the entire freaking gallery. And that's not good for mobile. That's not good at all. It's slow page speeds. And he was a savvy person who put it on Google Page Speeds. Like, you know, the score sets. I'm like, yeah, okay. So what do we do? A lot of people at this point be like, okay, that's a CMS. What you're talking about is a CMS. I need to change the content. I need to install WordPress or something. I need to give him the ability to log into an admin section and add images. And for the image problem, if you wanted to solve that by itself, I guess I got to make like some kind of process that transforms images to lower resolutions. Or just give me 2 versions of the image file, one's low res and then one's a high res for when you click on it. But that's not the only solution. That's where headless CMS comes in. So what is a headless CMS? A headless CMS is basically it's like a regular CMS. It manages your content. The only difference is that it's decoupled and agnostic to where the visualization happens. It doesn't care how you visualize that content. So like WordPress, for instance, You go in, you update a blog post, it renders that onto its ecosystem on your website. Headless CMS, API-driven headless CMSs, they just deliver all the content through an API. They don't care how it's consumed. So you can consume it on a mobile phone. It's just an API. You can consume it on a freaking smartwatch, a TV, I guess VR, according to this thing. As long as it talks to an API and speaks HTTP, like you can get that content. An example could be, say you have like a restaurant and you have a bunch of menu items, right? You want to show that menu on your website. Cool, HTTP request, give me my menu items, cool, display in HTML, awesome, done. But then you also want to create a chatbot where you can order from your menu through a chatbot. Cool, the content is driven by an API. I can just get all menu items. I can filter through my chatbot and boom, done. So this architecture is pretty clean as an engineer. Like, this is awesome. I can segregate my content from where it actually lives. It's great. Turns out there's a bunch of headless CMS providers. And by provider, I basically mean these are services that you log into. They give you a UI. You can add content. You can add images. You can structure your content. And then it saves it basically on their database. And then you call it through an API. Simplifies a lot of stuff. This is great. And I'm not going to show you, actually, yeah, okay, I'm going to use Contentful in this example. But all of these accomplish the same goal. They just do it in different ways. Graph CMS actually uses GraphQL, which is kind of interesting. I just recently found those guys. This is pretty cool. I only have experience with Prismus and Contentful, and I just did Contentful because of the great free tier, and they're kind of like the leading right now on headless CMS providers. So let's integrate that headless CMS into the static site that we built. First thing you got to do is you got to get your content into the headless CMS, into that provider. It's got to be on their servers. So I go through and I upload all of my images that my friend had to Contentful. And then you got to kind of build your domain, like what is your app, like database structure, sort of. You build what they're called content types. So our only content types that we really care about is that my friend has a photo gallery, and his photo gallery consists of multiple images. So the photo gallery, I give it a title, and I have basically a reference to another content type called image, which has a title and has a link or a relation to the media that I uploaded here. So I go through and I create one photo gallery instance. Actually, I create all the images first. On the right, you can see I just gave a title and I linked it to the photo. And then on the left, I created one photo gallery instance and related it to all those images. And they're kind of like a database, like a relational kind of structure that you just defined yourself. And in the end, I have a main gallery. All the content that I have on the CMS now is a main gallery and all the images that I created. So how do we put this into the static site? So we were good engineers and we kind of created our gallery service, kind of abstracted it, so it's pretty nice. So now all I have to change is the gallery service, which now talks to Contentful through a client SDK, a node client SDK. Instantiate an instance of it using your space, which is basically your project, and then your access token. Always put them in environment variables, just in case you push it to GitHub and you have to have access token public. You're going to see it later. I'm going to change it later because I need to publish this. And it has one function, get galleries. It's going to talk to the client to get all entries for a specific content type. That content type is an ID. You got to go to Contentful, figure that out. And it's going to give me all the galleries. I only care about one, so I'm just going to grab the first item and get all the images for that gallery. And now, how does the HTML change? There's two things that changed here. The image object shape changed. I could have abstracted that out, but I decided not to. I let that object change flow all the way down to my HTML. So basically, the object that was returned back from Contentful changed, so I changed the way that my templating service referenced each variable. Another thing was that Contentful, which is really cool, has a media API. So you can append query string parameters to all media hosted on their site, and you can manipulate that image. So here what I'm saying is give me the image, this image instance, give me that image but 40% the quality of the original image. So now my preview is 40% the original quality, but when I click the link, I'm going to open up the URL full quality. So that solved that's all my problems right there. So where are we now in this architecture? We killed galleries. We're no longer hosting the galleries locally. We're getting them from the Contentful API. So it's calling during the build, it's calling the headless CMS through an API and piping those galleries into my templating service and compiling to a dist. And still, the process of getting that distribution folder to the server is manual, which doesn't fulfill my needs because my friend can change content-folder and like I changed it. And like, okay.
Is there a cost for the headless CMS?
No, there's free tiers that are very robust, and we're only changing the content when we're only calling the API when your content changes. So a lot of people can use the headless CMS to call the API like all the time. We're only doing the content changes. We're not using much of the API calls. All of them have free tiers, and you can choose which one's best for your solution.
So once you have this headless CMS, you don't have to do like an FTP of the images?
No, it's all done through the UI. So now we have the problem that my friend has to call me every time he pushes to the headless CMS. I have to redeploy my project to whatever hosting provider that I chose. So let's talk hosting providers real quick. How can you host static websites? There's a bunch of ways. You can host a static website through Google Cloud Storage, Amazon S3, GitHub Pages. I'm going to show you Netlify because Netlify is catered around our use case that we're talking about right now. And also any traditional hosting provider like GoDaddy, HostGator, you can always FTP in there and change your files. We're going to talk about Netlify because of the suite of tools they have around our use case specifically. They kind of roll in the hosting and the continuous integration and deployment all in one, which is fantastic. So here's the live demo part that hopefully doesn't not work. So let's go to Netlify. This is my Netlify account. So all my code that I've been talking about is actually hosted on GitHub in my repo. And I have 3 branches. The first one is the basic phase 1, which is static. Second one is this the second process, which was the local kind of static calls, and the third one is going to be what we'll be integrating with. So Netlify, you can link it to a GitHub repo that you have. So I'm going to choose my $1 website talk. I'm going to go to phase 3 because he's ready for this. The build command was just one command, which was gulp. In the publish directory, so when Netlify gets a change in your code, it's going to run a command, and it's going to, after that command finishes, it's going to publish the folder that you tell it to publish after that command is finished. So the directory that we're publishing to was this. And now is the part where we're going to see my access token, which I will change. So I'm going to put an environment variable into the environment of my build that's happening. Which is my contentful access token. Now, deploy. So I can check out all my deploys here and click on it, and I can check out what's doing. What's doing is it automatically realizes I have package.json in my project. It's going to do an npm install. That might take a second. So I'm just like hang out a little bit while npm install works.
So since your gallery build function is inside your build process in Gulp, does that mean only on building the project is when it actually pulls the latest gallery images static?
Yes.
And because it is in the build process, you don't really expose any like secret keys and whatnot because that's all the behind the scenes.
Exactly. Precisely. So you're going through, npm install's happening, it's getting all my stuff. It's going through, and you can see that's calling my gulp commands. So build HTML, copy assets. At the end, it's like your site is live. Sweet. And they give you your own URL here. There it is. This is on a. I'm not done yet, though. This is your class. Check out this Flexbox. That's so cool. So it's distributed on a global CDN on the edge. It's static files. It's super cheap to build this. It's really fast too. It's fantastic. But that still doesn't solve the problem of when they change the content on Contentful. How does this know I got to rebuild my shit? You know, I got to do this again. So that's where webhooks come into place. So you can go into Netlify and you can hook up a webhook. You can set up a webhook that whenever you post that webhook, it's going to just rebuild your site. It's going to do a rebuild. So you go to settings, build and deploy. You add a build hook, and we're going to call this content changed. Save it, and it's going to give us an endpoint that we can just hit to rebuild our content. Whenever I hit this with a post, I can curl this, and it'll rebuild my site. What I'm going to do is I'm going to hook that up to Contentful's webhooks. Webhooks are pretty cool, guys. Add a webhook, and we're going to call this build site. Give it the URL. I can tell it to execute this webhook on everything, but I don't really care if the person comes in and saves their content. I care if they publish it. So in Contentful, there's this conception of publishing and unpublishing. I only care when they publish or unpublish or delete, so I care about deleting. I care when they unpublish. I care when they publish. I care when they archive. Save it. So now let's go back to deploys for Netlify. And let's go back to here. And I hook actually wait, I'm sorry. So let's go in as, now I'm my friend Andy who wants to change his pictures. Like I hated all those pictures except for one of those pictures. So he logs in, I give him an account to Contentful. That's the only interface he knows about his website, is that I go into this Contentful thing and I manage my assets. So I go through into the content. You can see this is all the content. And he wants to unpublish all these images. Don't unpublish the photo gallery though. We did not do any error checking. He only liked Festival Night. So we unpublished these. And I told Netlify to listen. I told Netlify to listen. Yes, there it is, sorry. I didn't press any buttons, this happened automatically. I didn't. Check the tapes. So Netlify was listening to the unpublished event, right? So I unpublished Netlify, sent sorry, never mind. Yeah, Netlify was listening to the unpublished event in Contentful. Contentful sent a webhook, a post request, and told it to build. And you can see it built in, what is that, like 20 seconds? Now I can go to the website. And there's all the images.
There's a couch.
Hard refresh.
Check your
Woo!
That's a lot down, so work. So there's that one image. So there's a CMS functionality to a static website. This is static. This is on global CDN. This is like super fast to deploy, really cheap to deploy too. We actually use Netlify at XO, and what we use in Netlify is a really cool feature that they give you out of the box. Oops. I'm going to go to phase 3, and I'm going to branch off of this. I'm going to change something in the code. Instead of saying photography, I'm going to say like Andy's photos. And I could have hooked up Contentful to give him access to change that header tag, right? I could have done that. I had full control as a developer.
What else available to you besides image assets to include through the API?
There's a bunch of kind of app types. There's dates. There's any custom assets that you create. There's text, like paragraphs, like markup, all that kind of stuff that you would expect from an user.
It's not a full WYSIWYG, so it'll do paragraphs for you.
I think so. We can look at that.
Keep doing what you're doing.
Oop. So now I made a branch, right? And you can think about this as like when you're working on a project with a team. Oop, I gotta add stuff. Damn it. No. Cool. Push the branch. I push to a branch on my GitHub repo with one change. Let's go to Netlify and let's see what happened. It's building again, but it's building a branch deploy. So building a stack website is so freaking cheap that Netlify is like, I'll build every single commit you push up to GitHub as long as it's part of a branch. And that's awesome because it's a preview deploy. So this isn't actually live. This is on a specific branch I can give to our designers and say, do you like this? Is this pretty cool? And they're like, yeah, it's cool. Let's merge that into master. I merge it into master, pushes off a Git, a hook, and it rebuilds the site in Netlify. So to wrap this all up, I just showed you. Where are we now in that process, right? So we hooked up. The build process is now happening on Netlify's servers, right? We no longer own that on our machine because that needs to happen so Andy can push it into headless CMS and happen on Netlify. We're also telling our headless CMS, in this instance Contentful, to trigger a build and publish on any content change. And now this little dotted line turns into a solid line, which means, because I made it mean this, that it's automatically pushing those changes to global CDN. And that's all I have. Questions? Yeah. If you have any questions?
I have a question. Okay, so you said that in the free tier, there are certain amount of API calls, right? See, images doesn't count towards that because you're up.
I didn't mention that specifically because, yeah, images. So
how do you get around
the image, the media API does have a certain amount of requests. So obviously, this is really useful in my instance. My friend, he's not a really well-known photographer, so not a lot of people went to his website. Yeah. But obviously, you're hosting images, you do some processing on those images on Contentful down, right? So if you do a bunch of requests, I don't know exactly how many requests it is, but I think it's pretty high up. It's a free tier, and then you have to pay for it. I mean, they're doing a lot of work for you at this point, so you might as well pay them for the work. Sorry.
So you can hook up any headless CMS you wanted. So if you wanted to write a plugin for WordPress that ran headless, you could do that.
So WordPress is headless technically because it has an API.
Yes.
So you can use that API to do whatever you want. So in that instance, WordPress at the API level is a headless CMS. Yeah. When you host it and you use that for your pages, then you're getting into the traditional CMS part. So does that answer your question?
That's exactly what I was
looking. Okay, cool. I'm sorry. Yeah.
For your friend, if his like URL is like andysphotos.com,
right?
Do you specify that in Netlify?
So Netlify can be used as like DNS, so they can manage your domain inside of Netlify. So you can create you can go buy your domain and use Netlify as your serverless. Yeah, that special word.
So yeah, on that. So Netlify, I missed the first few minutes. Is Netlify providing their own CDN?
I'm sorry?
Netlify providing their own CDN here?
It could be under the hood using Amazon, for all I know. They could be using AWS under the hood. But I mean, you can roll this entire structure up on your own using Amazon.
They provide the domain name,
yes.
rating.
Yeah.
Does that include HTTPS?
Yes, for free. For free.
$600 license.
They're using HTTPS through
SSL for everyone?
Yes.
Yeah, let's encrypt.
Let's encrypt, and
Yeah,
they're automatically updating your certificate for you.
Right, but if you use AWS CDN, make sure it's $600 a month for SSL master.
Okay.
So are they just even the cost of that?
I guess so. They never charge me, and I have like 5 sites with them, and they're all HTTPS.
And they handle the SSL.
Yes.
Yeah.
Any questions? Awesome.
You could save $600 a month by switching to that.
I should have called it that.
Just reminding me of those Geico commercials.
Yes. Let's Encrypt is fantastic, but they don't last as long as normal.
No, let's
For now.
AWS part. Let's Encrypt is easy, just automate that.
Okay. Yeah. But yeah, so awesome. Thanks, guys.
So I'm gonna take a few minutes to move over. So if you want more pizza or you want to grab a chair because you've been standing awkwardly in the back, yes, I see you, hon. Grab a chair and stuff while I move over. I'm gonna do the same thing when we get back. Let's move. Yeah, I got it. Thank you. Yeah, things one by one. My router. We'll go first. I have it ready. Oh, the power strip's not even on. That's why I have no skid strips on this thing. Oh, you're tangled up with one thing.
Curiosity.
Oh, don't worry, I'll try to say it. No, I just intend on giving a whole talk that has nothing to do with robots and just letting me sit here, right? And then like just walking off stage and just being like, no questions. Yeah, that's entirely my plan. I'm Derek's friend. Did you not expect me to be an English mastermind? Like. Oh yes, for a long time. Back the first time we met, his wife had to physically separate. It was fun. That was a fun day. Almost done. Moving crap inside the I drank all that beer. That was a phrase I often say. Make sure the video looks right. Oh, Inception screen. Just save the preview. Okay. I'm just about ready. I like it when things just work. With IoT demos, you never know if they're just going to work or not. It's an impact working. Oh my gosh, all my demos work tonight. That was the first. I'll be a very happy camper. All right. So heads up, I'm going to be streaming this on Twitch as well as talking to y'all. So anything you say will be recorded. I'm not going to point the webcam at y'all, but if you don't want to be heard on Twitch, don't say anything, I guess. Okay. And we're live. Yay. And one of my bots should turn purple here in a second. You better turn purple. I'm mad at you if you don't. I'm watching you. First, talk about serverless IoT and the new full stack. A little about me. I am a developer relations engineer at IOPipe. I'm not broadcasting. Oh.
Are you on Zoom?
No. Oh, that's right. I was supposed to take a link from you.
Yeah.
That's right. I totally forgot to do that part. I have Zoom though, so that part I don't have to install it or anything.
You want me to just tell you the ID here?
Yeah, that'd be great.
529 272 0960.
Doesn't seem to kill the echo. That's weird.
Is your Starbucks? What do you mean?
Oh, right. Wait,
Oh, right.
I need to turn off my actual laptop. Right, okay,
Laptop.
cool.
Right.
Okay, now let's install that. Make sure OBS doesn't like.
Okay. Now let's just call that.
No, we can't. Just kidding.
Are you muted?
Oh, I have to mute my mic.
Oh, I have to mute.
Muted. Maybe full screen. I love Zoom, I do. Okay, I'm still streaming apparently. What?
When you switch teams, you muted your microphone. You don't have any sound.
Why don't I turn
No,
off?
I just muted my mic on Zoom. My switch still has sound.
Oh, that's.
Oh, yeah.
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 Yeah, my switch totally still has sound. Thank you for scaring me, but yeah, my switch totally has sound. So, all right. Anyway, if they don't, yes, I will share my screen. Nope, that's not unintuitive.
Yes, they're actors.
I use them all the time for work. All right, there we go. Yeah. All right, now you'll get. Oh wow, it's like a 4-second delay. Cool. All right, so I'm gonna make sure to be very slow about this. Serverless IoT and the new full stack. About me. Eventually, a picture is gonna show up where I look a little bit like David Bowie. I am a developer, real engineer, and IO pipe. That means I build examples, I speak at conferences, I do all sorts of marketing and, well, not really, but more engineering, and I throw some marketing terms at people sometimes, and it's great. I have a bachelor's in science and computer science from 2011. I am currently obtaining my BSc in electrical engineering. Hopefully I'll be done in 2019. Depends on how 50Q goes this semester. I'm a baseball fan, go Diamondbacks and go Astros, the Astros especially. And people call me the node botanist for reasons that will become clear shortly-ish. I'm also a GIF connoisseur. Oh, come on. You're killing me, Smalls. Play the GIF. There we go. So this cat is like obsessed with this banana. Why is it lagging? My GIFs are gonna lag. But I'll live with it. So anyway, GIF connoisseur. What we're going to talk about today, we're going to talk about serverless, obviously. Otherwise, this talk would be called serverless IoT and full stack. We're going to talk about IoT because, again, serverless IoT and full stack. What about all the stuff we already use? We're going to talk about that as well. The new full stack, because I had to have my whole title in those bullet points. And how we're going to have to work together. So serverless, this is a fairly new topic. It's only been around for a couple years, but really like a year in terms of like most developers have heard of it. But it doesn't mean there aren't any servers. I actually despise the name serverless because there are very much still servers, especially coming from the Node community. I'm like, oh, hi, I just spent 7 years saying my language is valid on a server. You can't tell me the servers are gone now. Like, that's not fair. So what serverless is it's actually just a misnomer for the further abstraction of infrastructure from something you do yourself to a service you pay a provider for. It's the next step from EC2. So instead of EC2 where you go, okay, I've got my operating system and now I'm going to install Node or Ruby or Python or whatever, or I'm going to install a Docker container because Docker, I'm going to write a function and I'm going to say deploy, and Amazon Lambda in this case is going to go, okay, and I'm going to have a function. So that's why another name for serverless, which I like much better, is functions as a service. Because you write a function, the service runs the function for you. It's self-explanatory from that angle. I will use those terms interchangeably. What does it do exactly? You deploy functions to a cloud service, AWS Lambda, Microsoft Azure functions, Google Cloud Functions. Apache has OpenWhisk. We had a really good podcast episode last week on the serverless podcast with a guy who runs Kubeless, which is serverless on Kubernetes, which is an interesting debate about what was the point, but it was actually a really good point. The developer actually had really good points. Anyways, so you don't have to worry about the infrastructure with function as a service. You don't even know what OS is running on some providers. Amazon provides a Docker container of what they run your serverless functions in, but like not all providers provide that. So sometimes you don't even know what operating system you're running on. Most of the time you just say, I want node 8 or node 6 or if you're really weird, node 0.10, like, I don't know, I don't even think anybody supports that anymore. But the cloud services also take care of scaling and multi-tenancy and routing. I'd say they take care of debugging, but they kind of do and kind of don't, which is why I work for IOPipe. We do AWS Lambda monitoring services, and that's the last I'm going to say about that. But the point is, you write code, you hit deploy, that's about it. No more setting up EC2 instances, Dockerizing your application, writing a bash script to deploy to different instances. Who would never like to remember how to install Node on a Solaris EC2 instance ever again? I would like to never have to Google that again. Good God, installing Node on Solaris EC2. All right, but there's a warning with serverless. Just like every tool or architecture or bike shed, function as a service has use cases that are good and use cases that are not so good. There's tons of good writing out there, and I can give an entire talk about when and why functions as a service can be good for you. I'm simply covering basics so we can get into the fun of it. I am going to do a demo. Forgot about that. Thank you, slide. See, this is why I write my slides that way. I break a big demo slide so I don't forget my demo. Functions folder. Let me make this bigger because the TV people. I think that's big enough.
Give it a second.
Killing me, Smalls. Alright. Might be because I'm streaming. Hopefully the stream's not lagging too. We'll find out later. So I've got in here a handler.js. I'm going to open it. This code so you can see it. Apparently, there it is. I'm going to check one thing before I get much more angry at my Wi-Fi situation. No, I'm connected to the right Wi-Fi. Okay. Thought I was connected to that little router on the table, and that would explain why it was being so slow. Because that's where my bots are connected, and they're kind of chatty. So we're mostly caught up now. Sweet. So this is handler.js. Everything. So this is all in Node. This is on AWS Lambda, and I did have process environment keys. Only because I remembered it like 30 minutes before I left. Anyways, each module.exports.function will be mapped to a function on AWS Lambda that I can then call. I have GitHub event, Twitter tweet, Twitter follower, Twitch stream, some other stuff. And the reason I have those is they're social events, and they're going to work with that one right there, and that one propped up on Bowser right there. Let me show you how they map. I have a serverless.yaml. Why YAML? Don't ask. I don't know. Mapping each handler function, the handler.github event maps to GitHub event the function. It looks like it's mostly just like, it felt kind of repetitive, but it's so that AWS Lambda knows what node code to call when I call a particular function through AWS Lambda. So to deploy all of this node code, right, I have a package.json, I have a handler.js, and a serverless.yaml. To deploy this, hopefully the Wi-Fi is going to work with me here. Deploy. So serverless deploy. Serverless is, they're at serverless.com. It's called the Serverless Framework. They work with many to all of the providers of serverless functions, and they make serverless development in general much easier and nicer. Command line friendly. AWS Lambda is not always command line friendly, and who here wants to spend more time on the AWS dashboard?
Beautiful.
UX designers must not like you. But yeah, other than that, no, you don't want to spend more time on the AWS dashboard because who does unless they have to? So it's uploading everything. It's actually going to test everything out, and I'm going to let it run. Well, I go back to my slides, and I'll come back to this. Oh, right, so pixels. Play again. Yeah. Okay, cool. But serverless talks on their own are kind of dry, I've found. So I found that one really, really good case for function as a service is the Internet of Things, right? So here's, what do I mean by IoT? I get asked that all the time by people who are in tech and out of tech. What exactly do you mean by IoT? What I mean, and this is the definition crafted over months and months of painful debating with people, Any device that isn't running a full operating system with the sole purpose of providing a user with an ecosystem of applications for a wide range of uses, but still connects to the internet, usually used to collect analytics and surroundings and offer a simplified UI for a specific given task. What? Okay, so anything that isn't a fully fledged computer or smartphone, but anything they can be used in conjunction with them, in fact they often are. And they connect to the internet to complete specific tasks and or collect specific data. I really like that first example when someone tries to, well, actually me, and I go, I've done my research. It's not gonna work. But that's the response I give most people, is if it's not a full-fledged computer or a smartphone, and it's meant for a specific task, and it connects to the internet via Bluetooth, and then the internet via a phone, or just directly to the internet to complete that task or collect data, like sleep trackers, smartwatches, social bots, Amiibo, kind of. They connect to the internet through Nintendo. All sorts of stuff. So why does IoT matter to us as web developers? So I'm web developer invisible hat for a moment. And that's because as the lines between front end and back end have blurred to create the web development ecosystems we have today. I mean, hang on, this is the full stack meetup. Like, we're aware of the blending, right? It'd be weird if we weren't. Technologies around serverless and IoT are shifting the skill set of web developers, allowing you to do more with the same tools and services and abstract away what you're not already an expert at. In this case, EC2 management, server management, scaling, dealing with millions of requests. You're a web developer. You like to write Node, hit a button, and it runs. Or you write Ruby or Python, or whichever language you write. And you like to hit a button, and it runs. That's where serverless is shifting to. Let you abstract away the things you are not an expert at and worry about the things you are good at and allow you to do more with them. And with that, it's also relevant to note that as a web developer, you're likely to, at the very least in the future, create web interfaces for IoT devices. And it couldn't hurt to know a little bit more about the devices you're designing UIs for, because you've never used the thing that you're writing a UI for. That can kind of get in the way of you writing a UI for the thing. Like, I'm 99% convinced AWS developers never use the web AWS dashboard. They can't. They would quit. Anyway, their CLI tools are great, and that's why I'm convinced it's all they use. Anyway, not to mention, the boundary between software developer and firmware developer is eroding as I speak. And you may not believe me, but you might after these demos. Close your eyes for a moment. You don't actually have to close your eyes. You just have to trust me, which is asking a lot. And picture a firmware development environment and a firmware engineer. Imagine a C file, probably, a bunch of arcane tools with little wiggly graphs all over them, and some with a master's in robotics, hunched and pale and pasty. And, yeah. I mean, I'm hunched, pale, and pasty, but I don't have a master's in robotics. And no, that's not what a firmware developer is, because I'm up here and I'm a firmware developer. I developed the firmware for all of this crap. And I'll let you know a little secret. Just like when I was a web dev, I have no idea what I Google everything. All the things. I can't go a day without MDN, y'all. Really. How did this happen? People ask me that all the time, in and out of the context of this talk. How did this happen? Language engines. I'm going to talk about it in the context of this talk. I don't have enough time to talk about outside the context. Inside the context of this talk, language engines are becoming much smaller with comparable power to the engines that you see running on major computers. There are engines for JavaScript is my main expertise. So I know of JerryScript, IOC.js, and duct tape, all of which run under 64 kilobytes in footprint, and they can run with 4 megabytes RAM. And that's at their max. You can modularize 2 of those systems, JerryScript and duct tape. You cannot modularize Esperino yet, but they're working on it. Microcontrollers, also known as robot brains, are getting smaller, more powerful, and much less expensive. For instance, the Raspberry Pi Zero W, which is enough to get you started on an IoT device, is about that big, runs Node 8 and all your favorite languages, and it's $10. You can find it in stock. Good luck with that last part. People decided that they wanted to program hardware without having to use C all the time. And Okay, yeah, that's like totally a huge difference. You just totally like, you know what? I'm done. I forgot C++. You just said sorry, bye. Okay, anyway. We done? Cool. So with a dash of magic, there's the open source movement, and lots of people with way too much extra time on their hands. You end up with hardware libraries for nearly all popular programming languages on the planet. GoBots, NodeBots, RubyBots, PerlBots, which really cracked me up. I got it working and I was like, I never get regular Perl working. This was impressive. Name a language, there's probably a robotics programming language for it. There is a Fortran robotics programming language. I did not try it, but it does exist. So who wants to see some robots besides the ones you can already like literally see right in front of me, except you Twitch viewers. Hi, you can't see them, but I'll move them so you can see them if you're even watching. The social bot, that's this one. I'll put it up so my Twitch viewers can see it. It's got a pretty little rainbow and a pretty little LCD screen. And what it does is it reacts to Twitter events, Twitch events, GitHub events, and IOPipe events because I'm employed and I'd like to stay that way. If you tweet and mention NodeBotanist, or if I tweet or retweet or whatever, it turns blue and it says NodeBotanist just was mentioned in a tweet or just tweeted. Twitch, I'm at twitch.tv/NodeBotanist and I stream my open source work every Thursday night. If I get a new follower or I start a new stream, everything turns purple and it says NodeBotanist just yada yada yada. GitHub events, which I'll show you in a moment, because I'm actually going to do a GitHub push from here, depending on how the serverless deploy went. I'll have to check on that. And the IOPipe event is tied to the GitHub event because I was too lazy to write a separate event just for IOPipe, even though I love them dearly. Anyway, let's go back to my command line. Yay, our deploy worked. So all of that code is now running. And with AWS Lambda, the best way to get to it is API Gateway, and they'll give you a nice little HTTPS route to get to it. That S is important because certain robotics platforms looking at you, ESP32, have been very, very slow in their HTTPS request routing software. So that makes things interesting. But yes, it gives you HTTPS access to your serverless functions. Anyway, so how does that work? Cool. Would help if I actually wrote a message. Don't put ads, don't put exclamation points in your critical messages, Cass. I know you're excited. GitHub knows you're excited. You're fine. Origin. Yes, and yes, I know the backslash with the exclamation point would work, but oh, that's fun. I get news on my phone. It's not always a good thing in the middle of a talk. You sit down and you see it. Okay. Okay. So, provided my router is still connected to the internet, which probably is. These are still kind of cruising along there. Oh, the other thing the serverless framework can do, which will make me feel much better about what's going on here. Serverless. Invoke function Twitter tweet. So instead of having to go and find the API gateway URL, I just tell serverless, hey, go invoke that function for me. And just run it, and okay, it's there. Ha-ha! Okay, so for some reason, it's getting events very, very slowly. That might even be someone else's, who knows. But it lights up for social events. I did this because at conferences, people wanted ways to show off what they were working on when they were quietly like in a corner. Instead of like saying, I'm antisocial and I'm just gonna sit here on my laptop, it's more like, no, I'm pushing 50 GitHub requests because my boss decided this was a good time to push a release. Luckily, my boss has never done that. But I've had friends who've had that. And kind of nice, instead of that sitting in front of my laptop to tell people what I'm up to. And or there's rainbows, please feel free to come talk to me if you see rainbows. Or talk to your doctor, depending on if you're looking at the robot or not. Anyway, back to my slides. Pixels equals slides. Okay, so that was the social bot. It's slowly getting events. I'm really worried about the Twitch stream quality now, but I'm okay. It'll be all right. I can get it in editing. No, I can't. Name tag. This is little one propped up on Bowser here. It's got my name and my handle and what I do and an IP address because debugging. And then that little square, it actually got from the social bot. The social bot pinged my name tag and said, hey, I got a Twitter event. And name tag said, cool, I'm gonna put up a blue square. You got a Twitter event. So if I'm walking around, my social bot's not like near me, my social bot is still near me in my car. So this is an ESP32 rover kit. We'll pick it up. Thank you, Bowser. You've been very helpful. And so it came with this really cool screen, and on the back you can see the ESP32 chip, which viewers, yeah, and took me a little while, but I managed to get this running entirely in JavaScript using Esperino. So I'll show you the code for the name tag. Thank you, Bowser. He'll be even more useful shortly. Not that key. We're not on your mechanical keyboard one. Not that one. We're not that one yet. Oh, my computer's the one just being slow now. That explains it. Yeah. Let's see what all's running. Everything I need and nothing I don't. Oh, you're not plugged in. What am I doing? Your battery's gonna die. Stay plugged in. All right. That's not it. That's for the social bot. So actually, I can show you the social bot. Yes, this is the social bot code. So I actually wrote the library for the LCD. It uses serial port, so a USB connection to communicate with the Tesla. So I wrote the serial port library to make that work. And basically all it does is every 5 seconds, it parses a message off the queue and shows the correct color and message for that event, be it Twitter, Twitch, GitHub, or nothing. It goes back to doing rainbows. And then every 10 seconds, down here, get events. Of course, I just named my callback because of course I did. There's good. You walk through this like 80,000 times and then you go to show people the code and then you're like, where did I put things? So command explore. Here we are. So every 10 seconds, it goes to get events from AWS Lambda. So I have another serverless function running that all it does, so every time a serverless function for a social event is called, it dumps the event into a DynamoDB. And then I have a get serverless function that every time it's called, dumps the DynamoDB into a response and sends it back. So that's how that all works. The reason this is great cost-wise, Lambdas only run when you call them. They don't just sit there running, waiting for you to call them. They just only run when you call them. So compared to an EC2 instance, where you have it running 24/7 waiting for your requests, and you're paying for that 24/7, for the Lambda, you only pay for what you call. And so if I only have my social bot running like 1 day a month, even if I have a particularly social day, not particularly, I've never had to pay for Lambda. Except that one time. That was entirely my fault. Infinite loops.
Oh.
They were nice enough to refund me the 5 cents. They were like, yeah, okay. It was 5 cents. That's literally, my infinite loop cost me 5 cents. Now, if an infinite loop cost me 5 cents every time, that's broke. Anyway, that's my slides. And this code's all going to get pushed up to GitHub shortly after the event. These demos are from lots of different events, and some of them are new, so I'm still kind of compiling them all in one GitHub repo for y'all. Social name badge. I've shown y'all the social bot. On the go. Okay, so I like Nintendo little figurines. I know that the shortage is totally fabricated and they're making lots of money off of it, and I refuse to play scalpers. I just go to the store and buy them normally. But I love those little things. They're fun. They're cute. They're already painted. So what I'm going to show y'all, this is the Esperino IDE. So this is one of those JavaScript engines that I mentioned, and it doesn't like to zoom. Anyways, Espruino is a JavaScript engine that runs in less than 64K footprint, and it actually takes about 2 megabytes of RAM to run, which is great because I shoved it on the ESP8266, which is a postage stamp sized microcontroller that costs about $2 per, if you're buying them from a US supplier individually, they're $2 a piece. Otherwise, you can get like 10 of them for $2 if you're willing to wait like a month and a half for it to get there from Shenzhen. But that's the point. We're going to plug this in. This is what I've got. It's a Node MCU board, actually. I wanted to see how well they did the whole voltage regulation thing and the pins spread out. And they actually did a really good job. Plus, not having to solder that onto a board is a good day for me. And I have an NFC reader, MFRC 522, because that's the one that reads active, passive RFID tags. So the cool thing about the Amiibos when they came out, if you have a Nintendo system, you might know this, you can read data from these and you can also store data on them. So like when you're playing Mario Kart, if you want to save a ghost, so you like challenge your friend to a ghost, you like put the Amiibo on there, it'll save the ghost to the Amiibo, you can give it to your friend and it'll load onto their system. So they're like, remember those PlayStation 1 memory cards? They're kind of like those, only they look a lot cooler. So what I've got is 2 of them. I have Bowser and I have Luigi. I have an RGB LED attached to this little Node MCU. And what should happen when I hit upload, oh, I gotta hit connect first. Gotta know where it is. You can do it. It's just a serial connection. There, okay. I'm gonna hit upload. And so JavaScript's speaking SPI right now to get the MFCU 522 chip talking to it. So I'm gonna, okay, it's also connected to the internet. I don't know if you can see because it's really tiny, but it just mentioned to me that it's connected to my little router there and it is connected to the internet. I didn't actually have any time to do anything with the internet on this demo. I finished it like 5 minutes before packing up to get here. I touched Luigi to it. When I touch Luigi to it, maybe it'll work with Bowser first. Come on, buddy, work with me. Are you not seeing it? Is this the right code? That's also a valid question. No, so it's the right code. Did it not upload correctly? Yeah, it's just saying, oh, they're sending. We're trying again in a few moments. Apparently my computer does not like streaming to 2 separate services and running a bunch of robot code at once. Who knew? Oh, cool. Okay, so it looks like it worked this time. Wait, oh, new interpreter errors. Those are great. I might stop the stream just so I can get some of my CPU back. Bye, Twitch folks. Super sorry if anyone's actually still watching the stream. They'll put up a recording, probably. If not, sorry.
Where'd you source the NFC from? NFC chip.
What?
Your breakout board for the NFC.
Yes.
Where's that from?
Amazon.
You just found one on Amazon?
Yes. Amazon is a surprisingly good supplier of robotics parts. Lots of them on Prime. In fact, I got this one on Prime because I fried the other one that I had. Because it turns out they're 3.3 volt, not 5 volt. Or not the hard way. Voltage is important. Yes. Says the electrical engineering major. Okay. Okay, upload failed. But I have more CPU this time. So let's try this one more time, Miss Bruno. Work with me here. Come on, buddy. To be fair, it's not a talk if all my demos work. Oh my God. Prompt not detected, trying to recover. Oh, I know why. Ha, it's because I forgot to get rid of that save comment. Get out of there. For some reason, whenever I try to save the code to this chip, and it's not the size, because I've had much bigger scripts saved to this chip, it does not want to save it. All right. No errors. Bowser. Okay, so that's JavaScript speaking SPI. I'm just gonna do it one more time because it's just so satisfying. Y'all think I will leave this plugged in after the talk. You will come find out how satisfying it is, especially when you coded it. Anyway, so all it's doing is I kind of helped fix some bugs with this library. Basically, the NFRC chip polls the surrounding area. It says, hey, are there any RFID chips nearby? and it waits for an RFID chip to say, yeah, I'm of this type. And then the reader responds, cool, I support your type. What's your ID? And it responds, here's my ID. And that's as far as we've gotten writing the drivers. Eventually we'll be able to say, cool, hold on to this data for me. And it'll go, great. And it'll hold on to that data for us. And that'll be fun. But for now, we're slowly converting things over. That's one of the things I do on Thursdays when I stream is I convert libraries from other languages into Node, mostly to show other people how to read the other languages, not to do anything like oh my god. I never claimed to be a genius, and I will never claim to be a genius. Just insane. Okay, so the Amiibo stuff, that worked. Cool, but it's not just the robots themselves. Oh, no. We have much bigger plans in the NodeBots community. The tools behind the bots are also things that we are rewriting in Node. Because Atwood's law, if it can be written in JavaScript, it will be written in JavaScript. For instance, if you've worked with AVR chips of any kind, you've probably heard of AVR Dude, which is a really ridiculously arbitrary acronym. So my friend Suze decided to make an equally arbitrary, but also awesome an acronym for girl, AVR girl, which does the same thing, but it's unit tested and it's written in JavaScript. Did y'all know that AVR Dude has no zero unit tests? It's used in production at places like NASA, and it has 0 unit tests, and it has not had unit tests for the entire 18 years it's existed. That makes a tiny vein in my forehead just kind of fall down a little bit. No unit tests? You're deploying that on stations. Okay. Anyway, AVR Girl is unit tested. So what I'm going to do, I'm going to unplug the MCU. And right down here is a SparkFun Pocket Programmer, which translates computer binary into AVR binary. And I have an AVR chip. And I have an LED attached to it, but I burnt it out. So you're just going to have to trust me when I say this works. I know, I'm asking a lot. I'm going to plug in my programmer. The lights on my programmer turn on, so you know I'm not just completely hand-waving. And I'm going to go to my command line over here. And I'm going to close this because I want to open up a different window. Back to the terminal. Go back to the terminal. Come on, Apple, you know better than this. Code here. Okay. So I'm going to show you my makefile because what I'm writing here, I'm writing a JavaScript library for a different tool called the Bus Pirate, which is awesome because it can emulate I2C and SPI devices, and it can do lots of different protocols, and it's $30 as opposed to another tool I'm going to show y'all later, which is $300. So if you're a hobbyist, this is much more attractive. And I'm writing a library to let you use it in Node, but I wanted an actual AVR chip device to test it on. To say, okay, does my I2C sniffer actually work, or am I just like, are my mocks of the hardware just kind of like making me think it works? So I'm writing an AVR program to do that. Now that's in C. That is the only thing that I write in C. And you'll know that because you'll hear expletives from North Austin, because that's me yelling at it. So Zach's turn, main.c and a main.o and a main.elf and a main.hex, and then a bunch of phonies. Ha, makefile joke. And then I've got all, which turns O to elf to hex and then flashes it. And so you'll notice some of these have -AVR Dude. That's because I used to use AVR Dude. But, and I left it there for legacy support because someone else who was working on this project with me does not want to use AVR Girl. And that's cool. That's cool. I like unit tests, but you do you. So I've got node scripts, AVR Girl checksig, AVR Girl flash, and AVR Girl erase. So checksig, this one's important because it makes sure I got my wires correct, because I never get my wires correct. How do I make the Zoom interface go away on my screen? It's not on there, but it's on here. It's driving me nuts. All right. So I use yards because this is a command line interface, and I don't want to have to deal with that myself. I'm going to try to make this smaller. Again, sweet. So chips is require AVR Girl chips JSON, which if you've ever wanted to know everything about every AVR chip, there's a JSON file out there with, it's a huge JSON file full of all AVR chips, which is great because I need it for AVR Girl USB Tiny ISP, which is the library which will run this demo, because it will use Node to control the programmer, take the hex file, and place it on the AVR chip. or check the signature, or even erase it. Luckily, it's event-driven, so I just say AVR rule, I'm ready, and then enter programming mode. And then when you're done entering programming mode, get the chip signature, and then make sure it's the one I sent. We're gonna try that now. Make check sig. Because I wired this with help. I didn't wire it right. Neato. Oh, I can make this bigger. I'll make this bigger for y'all so you can see my error. The error of my ways. You know what I bet? Wait a minute. Hang on. This worked earlier. Why is it here? Huh. Check sig. Hey. Live coding, it's the best. Check sig. Where are you? Okay, no, okay, AVR dude agrees. Dude and girl agree my wiring is off. I mean, even as a non-binary person, if dude and girl agree, I'm probably agrees too. All right, so, one demo doesn't work, and this is that demo, but there is a way to flash AVR chips with JavaScript. And I actually proved that it worked by proving my wiring didn't work. That's a win. I'll take that as a win. Suze can be right and I'd be wrong. I can totally win with that one. Suze is way smarter than me. So the digital analog discovery 2. I discovered this particular device while working through my electrical engineering degree. I'm going to hold up it along it with what it's probe attached to, which is an Arduino Uno and a RGB light and gesture sensor. I'm going to plug this in to my computer. I'm going to plug the Arduino into power. And so it's a portable electronic tool bench. It's got an oscilloscope, it's got a logic analyzer, which is what we're going to use here. It's got a spectrum analyzer. That's still attached. A spectrum analyzer, all sorts of stuff. So I'll show you in a moment through their software. Only downside is, unless you're a student, it's $300. But if you don't have any of the equipment, the actual equipment is way more than $300 once you've bought all of it. So, if you don't have any of the equipment, it can be a trade-off. Or if you need it for a class and you get a student discount, that's also pretty rad. So the Arduino Uno is preloaded with a sketch to load the I2C base gesture and color sensor and tell me the color of it. And what I'm going to do is I'm going to show you a JS script I wrote to do the logic analysis for I2C because I didn't want to do it through the GUI every time. I just want to hit one button, not 6 buttons. That's the key to UX design, by the way. Why hit 6 buttons when you can hit 1? Except in the case of deleting your bank accounts, I guess that'd be bad if you just do that with 1 button. But whatever. Here. So I'm loading up the software that it interfaces with. Hopefully it won't yell at me and say, yes, you saw the device right away. So yes, I2C analysis, that is what I want. Okay, so I can't see, even though y'all can see. So the way this works is you set up tools over here on the left, and then, so I have a logic logic analysis tool set to I2C with clock and data, and I have the probes hooked up to the clock, data, and ground of the sensor, because if you don't ground it, it won't know what to look for, which took me about way too long to figure out last time I was trying to run this demo. So here we got a script. Logic1.run, true. True means I actually want you to run. They're new to JavaScript at Digilent. I'm going to give them a break on that. So I've got a for loop that goes through all of the events and prints out if it's a start event for I2C or if it's a stop event for I2C or what address it's writing to. And then it actually writes it to a text file. So instead of reading it out of the GUI, which occasionally crashes and makes my day hell, I can read it out of the text file. Which if it crashes, I can just reload the text file. I'm gonna run this. Script, run. And I'm gonna change the color and put colorful stuff in front of my, put colorful stuff in front of my color sensor. So you can see all sorts of fun stuff. Try something completely dark. Oh, wow. You know what? We're going to rerun you with fewer samples. Oh, no, we're not, because that's the default. All right. we're gonna run this again. And it's gonna go faster. It's gotta go faster. Why do you take 5 seconds when I'm running you at home, but when we're standing in front of a bunch of people, you take like 30 seconds to pre-fill? And yes, I'm arguing with a laptop. Don't question. All right, whatever.
Can you shut down some of the stuff you're doing?
It's not CPU at this point, because I actually have the, it's not CPU at this point because the fan's shut off. That's actually how I knew I was in trouble. My little MacBook Air, I didn't know it had a fan until I started streaming. And I was very aware it had a fan very quickly. Anyway, but no, the fan shut off. It's fine. The CPU is fine. I'm going to open the file from the last time I ran this with the idea that it'll be there. I think code's still open to that folder even. Code. How do I get the sidebar back? Whatever. Fine. You've made me resort to the last resort, computer. Okay. No, that's why. DB2. Text. Bam! So, that actually might be from this one, because it may have taken me so long to find this file that it might actually have been done by now. So, start. H39 is the address. So when you run I2C, you can run lots of different devices on the same bus, and they all have a different address. This one's address is 39 in hex. And it's trying to write, it acknowledges, that means the device acknowledged that it's being written to, and it wants to write to register 94. Acknowledges, reads from 32. NAC at the end of a read means, cool, we're done here. That's something that took me a long time to find out as well. Anyway, so yeah, scripted that in JavaScript, so instead of having to look at it in a GUI, I could look at it in a text file, or better yet, parse it with regexes through a text file. Because if regexes don't make you feel like a wizard, you're in the wrong profession. All right. So, big kicker is every single demo on this table was in JavaScript. And if you don't like JavaScript, that picture's for you. Where is your God now? JavaScript is literally everywhere. Wah! Anyway, okay, done with the evil. The serverless? Oh yeah. The bots? You betcha. Everything was in JavaScript tonight. But I don't like JavaScript. Okay? If you think that's actually going to offend me, then no. That's okay. Nearly all major languages now have robotics libraries. You can use whatever language you like. Python actually has just as robust a robotics community as JavaScript, and we often swap code a lot because it is surprisingly easy to translate Python to JavaScript and vice versa. As in, like, you can kind of do it with an AST and a regex parser. Anyway, you might be asking at this point, or asking, will they shut up, or how to get involved. How to get involved, you build stuff. You learn stuff from building stuff. You write the stuff down that you learn so that other people can learn from the stuff that you already did, so they don't have to do it themselves. Because you share the stuff, because open source is the best, and closed source and proprietary bullshit is exactly that, bullshit. And then you repeat. You build another thing. You learn some new stuff. You write that stuff down. You share it with others. You continue forward, and everything gets better. Everything on this table, I did not write literally all the code for everything on this table. I obviously did not invent the digital analog discovery 2. I wouldn't be here. I'd be working for Digital. I didn't make the Tesla 2. I work on the CLI team, and I've made some patches to the firmware, but I didn't write all of it. So that's what I do. I build stuff, I learn it, I write it down, I share it, and I repeat. Thank you for listening. I went really long, but I had robots, so hopefully you'll excuse me. Carl Sagan thinks you're awesome, and so do I. My Twitter handle is NodeBotanist. I am, again, a developer relations engineer at IOPipe. We do AWS Lambda monitoring, so if you use AWS Lambda and you never want to see CloudWatch again, talk to me. And twitch.tv/NodeBotanist. I stream every Thursday night from my laboratory. There are cats and robots and possibly expletives. It's all in good fun. I think, yeah, it's on the slide. So, thank you. Questions? Can I do questions? Yes.
What's the story about hard real time in JavaScript on a device like that?
Yes, so the thing about hard real time is we have async await now, for one. Two, usually engines that are meant to run on small hardware processors that need that kind of real time have a sleep delay function built into their JavaScript engine. Espruino has one, Ductive has one, JavaScript has one.
what is this, just in general? What are you talking about?
Oh, real time meaning, so robots are like super specific about when they want their ones and zeros, otherwise they tend to kind of lose it. And JavaScript as a language, when you look at it, you don't think, oh yeah, I totally use this language for setting ones and zeros in exactly precise timing. Yeah, no, that's not what you think of when you like JavaScript. So what he was asking was, how do they do that? And I was saying the engines that go on these chips, they have special C level, because Node is written in C, which still surprises some folks. So these engines are written in C, and they tend to write a function for JavaScript that allows you to pause or tell the CPU, I want to interrupt and run at this exact time. Any other questions? Cool. If you think of any, at NodeBotnist on Twitter, I like to answer questions. And if you want to come up here and play with anything before you leave, let me know. I'll plug it back in and get it all running again. Yeah, thank you.
Thanks everybody for coming. There's plenty of pizza left if you want to take some home. And stickers, business cards up here, just a reminder. But thank you guys for coming.
Thank you.